All right, so we got a congruent triangle example going on here. And first off, I want to say that these probably aren't real triangles. Because real triangles, the sides have to be certain values because the sides are tied to the angles. This is purely an educational endeavor, and it has nothing. They're not real triangles. But we can put the real numbers in there. I don't know if we could actually make the triangles. But let's say we go around here. There's how many different parts are there that have numbers, that have measurements? Yeah. There's 6 parts. 3 angles and 3 sides in each triangle. So in each triangle, there's 3 points and 3 sides. So, do I have all 3 angles here? No, I'm missing this guy right here, aren't I? Do I have all 3 sides? That side's 11. Do I have this side? No, so highlight that. Do I have this side? No, so I'll highlight that. Do I have this side? No, and I'm missing that angle, and that angle. Now, I'm going to show you the easy way, and then I'm going to show you the way that you're going to do it. Formally when we do proofs. You're not going to like it. Well, that's not true. You're going to like it. Now, what angle corresponds with angle A? X. So if A is 50 degrees, I forgot to put the degree mark. What's X? 50 degrees. If angle C is 30, angle C corresponds to which angle? Z. So I know that's 30 degrees. Now I got to figure out what this guy is. What theorem do we know? Yeah, you add up the angles and you get 180 degrees. So I say 50 degrees plus 30 degrees plus the measure of angle B is equal to 180 degrees. So what's 50 plus 30? All right, so that's 80 degrees plus the measure of angle B is equal to 180 degrees. So how much is angle B? 100 degrees. Measure of angle B is equal to 100 degrees. So that guy's 100 degrees. So this guy is 100 degrees. All right, now, I don't know BC, but BC corresponds to the side that has one angle that's 100 and one angle that's 30. So you look in this triangle, there's 100, there's 30, there's the number 13. So this guy is 13. And so what's AC? 17, because AC goes from 50 to 30 degrees. 50 to 30 degrees is a 17 side. Now 50 to 100 degrees, I don't know here, but 50 to 100 degrees here is 11. So all you have to do is fill them in. And if I took this triangle, picked it up, put it right on top of the other one, would they look exactly the same? Yeah. Now, the logical flow. You've heard me talk about this. And this is how, when we get into... There's 2 types of math. One math we just did, where we just get the answers and we're good to go. Where we don't have to explain it, we just get the answers and we're off and running. We go on to the next problem. Then there's a different side of math, where you have to explain everything that you did. And you have to be extremely formal. I call it, there's beach math, and then there's prom math. Beach math is where you just go bam, 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 I'm done. No formalness, you're in shorts and a t-shirt or a bathing suit or something like that. But prom math is when you're wearing a tuxedo, wearing a nice dress, you're all got the makeup and the hair done. It's the formal math side of stuff, which, believe it or not, ladies and gentlemen, you have to learn. And you have to learn how to do this. And all it is logical thinking and explaining what you did step by step. That's it. It's you articulating the fact that, all right, I know this is 50, because I know that these angles are congruent to each other. Here's what that would look like. When I found angle X, I would say that angle A is congruent to angle X. And there's a reason for that. And I won't get into the reason right now, but that's your first step. That angle has to be congruent to this angle. Now, the next step says that the measure of angle A is equal to the measure of angle X. The next step says, well, 50 degrees is equal to the measure of angle A. So if 50 degrees equals measure of angle A, what can I say about the measure of angle X? 50 degrees has to equal the measure of angle X. This logical flow, starting with just this fact, because the only thing we're given is here. This is your starting point. So this tells me since they're congruent, the angles are congruent, which means their measures are equal. I know one of the measures, so I do some substitution or some. This is there's a law for this. I'll tell you what that is later because my brain isn't working at the moment for that. But that tells me what we go. This is your logical flow. We'd actually take it one step further and say with reasons for each step. And the question becomes, am I going to have to do this? And I'm going to say, yeah, you're going to have to do that. If I want to know the reasons why BC, why is BC equal to 13? I would say this. I'd say, well, since the triangles are congruent, since triangle ABC is congruent to triangle XYZ, the next step says that segment BC is congruent to segment YZ, which tells me that BC is equal to YZ. But I know YZ is equal to 13, so therefore BC has to be equal to 13 as well. And this is the logical flow. It is, I would consider this the extremely wordy version of mathematics, where you have to go step by step by step and say everything that happens. Now, proofwriting is like this, where you start with the given and you end up with the 13. And you give a reason, you give a step and a reason, step and a reason, a step and a reason, a step and a reason. It is the Sherlock Holmes version of mathematics. It is, you are a mathematical lawyer, prosecuting attorney, because they can only deal in fact, and you're giving your closing argument. This is true because of this. This is true because of this. Then this is true because of this. Then this is true because of this. And therefore we have our answer. That's what we got to be able to do. The thing is, don't make it harder than it is. Never make it harder than it is. Sometimes you'll get some nice, easy problems like this, where you just get to do some straight old math. And sometimes you'll get some proofwriting, where they call it proofwriting, but it really is creating a mathematical argument to show that you're right. And basically, you're proving beyond a shadow of a doubt that you are, 100% correct. And that's what you want to do. No crazy arguments, no illegal mathematics. It's all based on your theorems, your postulates, your laws. Corresponding parts of congruent triangles are congruent. That's a theorem. The idea, the definition of congruent triangles, stuff like that. It's all based off of these reasons why things happen the way that they do. And that's what your future has. Now, we need to be able to work really well with congruent triangles, because it doesn't go away with the triangle unit. This is going to happen. This is going to work with polynomials. This is going to work with the trig. This is going to work with when we get into three-dimensional shapes. So this stuff doesn't go away. It doesn't. This is, of the things you have to master, parallel lines cut by transversals is one thing you have to master really, really big time. And this idea about triangles and everything you can find out about triangles and everything you know about triangles, and then proving that they're congruent to each other. Because those two things, every other shape can be built out of triangles. And when we break it down, we're going to break it down to triangles, because triangles are the easiest shape to work with. So we really have to know our triangles.